This is example 4.2 from Discovering Design with Chemistry by Berean Builders. The first one asks, what is the ground state electron configuration of silicon? So first let's find that. So this is one of the ones you're supposed to memorize. It's over here, number 14. That means we have 14 electrons to deal with. So we're just going to start walking through the periodic table, going row by row across, over and over, until we get there, and go through all of those orbitals. So the first one we pass through is the 1s orbital. S orbitals hold 2 electrons, so we can put 2 of them there. And we have 14 to work with. So I'm going to keep a tally over here. Actually, let's keep a tally marks so we don't get lost. Next we have, so we finished this row. Now we're going to start on the next row. We're going to pass through another 2s orbital. Another s orbital. This one's 2s, which means it holds 2 more electrons. Then we're going to pass through the other part of row 2, the 2p orbital. The 2p orbital. Now, p orbitals can hold 6 electrons. That covers 6 more. So 1, 2, 3, 4, 5, 6. So we're almost there. Now we've gone through, in case you forget where you are, we've just finished 2p, so we've just finished that row. So next we're going to hit this row. So next we're going to go through the 3s orbital. Again, s orbitals can hold 2, so that takes care of 2 more, which means that we only have 2 more to go to finish out our 14. And you can see that because there are 2 more elements that we haven't passed through over here. We're now in the 3p orbital, and although it can hold 6, we don't really need, we don't have 6 more electrons to deal with, and so we only have 2 more. And I can tally them up. And you don't really need to tally them up if you just keep track of where you are and how many are left. But like if I didn't tally them up, I could see that when I got to the 3p orbital that I was going 2 boxes in to get to silicon, and so I didn't really need to tally them up. But it just makes sure when we're just starting that we're keeping track of where we are. Okay, so let's do the next one. The next one is palladium, and that is, they gave us the abbreviation. The symbol is PD. So if you look, you can find it right here in the middle of the orange section. So we're going to have to go through a lot of rows to get to this one. So we're going to start again up here with this row. And so and you can see that palladium takes 46. We're not going to write all of those tally marks out, but you could if you wanted to. So we're going to start with 1s. That will hold 2. Palladium's way down here, so we're going to keep going. So next we're hitting the 2s orbital, which will hold 2 more. And then on that same row, we then hit the 2p orbital, and p orbitals hold 6, so we'll have 6 more. We just finished the 2p row, so now we're going to the next row after that, which is the 3s orbital, which can hold 2 more. We're going to continue on over here to the 3p orbital, which will hold yet another 6. And then we just continue on around to the next row here to the 4s orbital that holds 2 more. And then we're continuing into the middle section. This can get a little bit confusing because our numbers don't seem to line up right. But if you read the text, you can see why that works. We're 3d. Now, the d orbitals can hold 10. And let's pretend you can't remember that it holds 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see there are 10 elements in that row. So if you've forgotten that, you can even just count them. Next, we're continuing into the 4p. I really should have written this where I had a little bit more space, and that can hold 6 more. And then after this 4p row, we're ending right here. So we're continuing on to the next row. We have the 5s, and that can hold 2 more. And then we're going to keep going into this row, but we're not going all the way across. So we really just need to count how many we're using. 1, 2, 3, 4, 5, 6, 7, 8. And so we're going to finish out with the 4d orbital with 8. I apologize, it's a little bit messy because I had to squeeze them all in. But that is the final electron configuration for the electrons in the ground state of palladium.